Hello and welcome to the screencast for Chapter 8. I think this is joints. So the first thing we want to understand or cover is these two different ways of classifying joints. We are going to have functional classifications, which we'll go over in lab, and structural classifications, which we'll also go over in lab. So remember, if we ask for what is the functional classification of this joint, it is one of these three words down here. So if a joint is referred to as a synarthrosis, that means there is no movement available at that joint. This would be like the sutures that hold your skull together. Not a lot of movement. Or I should say no movement, right? Amphiarthrosis, slightly movable. An example of this you would know is your intervertebral discs, or the symphysis joints in between all of your vertebrae. Little bit of movement, but not a lot of movement at that specific joint there. And then diarthrosis is freely movable. That's your arms, your legs, your fingers, everything that you can move around. Then there are structural classifications. This has to do with what is holding the two bones together, or whether or not that joint has a joint cavity. So there are going to be fibrous joints, cartilaginous joints, and synovial joints. We're going to cover all of these specifically, so you're going to need to know 3 different fibrous joints, 2 different cartilaginous joints, and then we're going to go over the 6 different types of synovial joints. So starting first with the fibrous joints, there are going to be 3 types, as this says right here: sutures, syndesmoses, and gomphoses. What makes them all the same is that there is dense fibrous connective tissue that holds them together. So think a really small ligament or some sort of stitching that's made out of dense regular connective tissue. And there's no joint cavity and no movement available. So it's 2 bones stitched together with very tough fibrous connective tissue. So before we talk about these 3 types of joints specifically, for each one you want to be able to describe the joint and give an example of where you would find it in the body. And that'll make more sense when we get there. So first up are the sutures. This you don't really need to describe so much. It's, as this says here, very short connective tissue fibers that are knitting 2 bones together. And you already know what a suture is, so these are the joints that hold together your skull, is what you would give for the example. The syndesmosis is 2 bones connected by a very short ligament. There is only one in the body that I am aware of, which is the distal joint between your tibia and your fibula. So the distal tibiofibular joint would be your only syndesmosis. Then you have gomphoses, which the book describes as a peg and socket joint, and this is how all of your teeth are stitched into your jaw. So those are your 3 fibrous joints. Then we're going to have 2 cartilaginous joints, where now it's cartilage that's holding the 2 bones together. These joints also do not have a joint cavity, but that is really not all that important to understanding them. So there's going to be 2 different kinds, synchondroses and symphyses, which each have a different kind of cartilage holding them together. So again, for these, you want to think of understanding the description of these 2 types of cartilaginous joints and knowing examples of where you find them in the body. So first up is a synchondrosis. The definition of a synchondrosis is when you have hyaline cartilage that is gluing 2 bones together. These are all synarthrotic, and examples would be where you have epiphyseal plate cartilage basically gluing the epiphysis onto the diaphysis of growing bones, and then the joint between the first rib and the sternum. The rest of the ribs do adjoin to the sternum via cartilage or hyaline cartilage, but those are all synovial joints. Then you have symphyses, and in a symphysis joint, the defining characteristic is a pad of fibrocartilage in between the two bones. All of the symphyses are amphiarthrotic, so there's a little bit of movement allowed. And there are two examples of the symphysis joint in the body, the intervertebral disc and the pubic symphysis. Then we get to the synovial joints. We are going to consider all of the synovial joints to be diarthrotic. This is a bit of an oversimplification, but it makes our life easier. We can say that all of your fibrous joints are synarthrotic, your synchondroses are synarthrotic, your symphyses are amphiarthrotic, and your synovial joints are all diarthrotic. So the first thing about synovial joints that you need to know is one of our possible open-ended style questions, which is the 6 features, anatomical features, that all synovial joints have in common. So if it's a synovial joint, it's got all 6 of these things. First of all is articular cartilage or hyaline cartilage, which is coating the ends of the bones. Then there is a joint capsule or articular capsule. You do not have to worry about the description of the capsule seen here. You just need to know the capsule. So here's an example. There's the hyaline cartilage. Here's the articular capsule. That is going to be, or I should say, that is going to define a certain potential space, which is called the synovial cavity. That synovial cavity is going to be filled with synovial fluid. This is slippery fluid that provides lubrication so that you have smooth hyaline cartilage rubbing up against smooth hyaline cartilage with lubricating synovial fluid in between, and it makes the joints very efficient, freely movable, and reduces friction. All of your synovial joints also have reinforcing ligaments and a rich nerve and blood supply. So it's going to be articular cartilage with an articular capsule that defines a synovial cavity that's filled with synovial fluid and held together with reinforcing ligaments, which is this thing right here. Then there are other structures that are found in some synovial joints, but not all synovial joints. So first up is a bursa, which you just want to know is a small sac of synovial membrane that contains synovial fluid. And as this says right here, it acts like ball bearings. So here, this is the head of your humerus. So this is your shoulder joint, the top of your humerus as it plugs into your shoulder. And this is a ligament, the coracoacromial ligament. It doesn't matter which one. But it's one of many ligaments in your shoulder that the head of your humerus might rub up against as it rotates and moves around in your shoulder socket. This bursa rolls back and forth in between so that instead of the head of your humerus rubbing up against the ligaments that surround it, you have this sac that rolls in between the two and reduces friction. You also have in some of your synovial joints tendon sheaths, which is anatomically or sort of made out of the same stuff as a bursa, only it's wrapped around a tendon. But they're both really the same thing, and they both reduce friction. Then, this is also a possible open-ended question, is to know what the major factors that stabilize your synovial joints are. So this is what keeps you from blowing out your knee, what keeps you from dislocating your shoulder, what holds your joints in alignment. The first factor is the shape of the articular surfaces. As this says right here, that plays a minor role. Most of your synovial joints do not have deep joint cavities where one bone is nested in another, which prevents it from moving. Like if we go back and we look at this joint here, right? Here's the socket for your ball and socket of your shoulder, only your socket is not very deep. So the shape of this bone is not preventing that bone from moving very much. So the shape of the articular surface in that joint is not providing a lot of stability, and that's the same for most of your joints. So there are a number of ligaments, the supporting ligaments that hold all of the bones together. They're going to run from bone to bone. They are more important than your synovial joint, but not as important as muscle tone. So this, you need to know, is the most important of the stabilizing factors that keep your synovial joints in alignment. And you also, or I would also like you to know what I mean by tone. So tone does not mean, or I should say muscle tone, does not mean the appearance of having toned muscles. It means that your nervous system is constantly stimulating every muscle a little bit, so there's always a certain amount of tension in each muscle, and that tension crosses the joints, so there's always tension across each synovial joint in your body, and that keeps all of your bones aligned. So then we get into different kinds of movement. These are the movements that we are going to use to describe what is possible at a joint. You are going to see later on that there are different movements that describe what individual muscles do, and we'll talk about those more in lab. So you just need to be familiar with these. And without being in front of the room and gesturing, it's hard to give examples of these. But gliding would just be like, imagine two flat pieces of wood sliding back and forth. So the angles between those two pieces of wood are not changing, or if you rub your hands together to warm them up, right, that would be gliding. Uniaxial movement, as this says here, is movement in one plane. So this would be like how a door on a hinge works, right? There's one plane of rotation, or plane of movement, through which that door can move. Biaxial means there's movement in two planes, and I can't come up with an everyday example of what does that. Your fingers can do that. The joint at your knuckle between your finger and your palm, you can open and close your fingers, make a fist or straighten them out, and then you can also wag your fingers back and forth, which is biaxial angular movement. Multiaxial means you can change the angle between two bones through 3 or more planes. So think about how your shoulder works or how your hip works. You can do angular movement in almost any plane you want to. And then circumduction is kind of the ultimate multi-axial angular movement, where if you can move through all of the possible planes, then you can make a circle, and that's moving something in a circle. And then rotation is non-angular movement, so no angles between bones are moving. And these will become more clear when we get through some of the different joints that we're going to cover. So we are going to stop there because I only get 15 minutes on this recording application. And then in the next video, we'll start with our synovial joints and we'll talk about the descriptions of all of these joints and what kind of movements you can get at each joint. Thank you for sticking with me so far.